Okay, we want to look at now the construction of a graph of an exponential function. And the characteristic of an exponential function has certain similarities to the characteristic of a power function, but there's a significant difference. Okay, the y value is the one that doubles under certain conditions. And the condition is that the x value changes by some fixed amount. And we're going to call that, so I could say which we call the, quote, doubling displacement, the doubling displacement. Now, since the y value is doubling when x changes by this amount, it makes sense to call this a doubling displacement, or the doubling displacement. Okay, and that doubling displacement is represented graphically by an arrow. The arrow, if this is the x-axis, simply represents how far you have to go along the x-axis in order to double the y value. Every time x changes by this amount, the value of y is going to double. So I'm going to draw several of these arrows, as many as I can get into this section of the x-axis. Now notice I don't have a y-axis. I will eventually need one, but I can put the y-axis any place I want to. And I can do that before or after I specify these doubling displacements. So right now, to keep my options as open as possible, I'm going to specify the doubling displacement and leave the y-axis totally out of the picture. So, I'm then going to pick an x value that corresponds to the end of one of these arrows, the beginning of the next, and I'll pick an x value here. Okay, so here's my x value, and then I'm going to choose some point directly above that point on the x-axis, and that will be the y value of this point. Now, that point determines everything else. That point, given this doubling displacement, determines everything else, because what happens? Well, I've got a double y. Well, here's my y, so I can take my compass and put those points, one point in the middle of the x-axis, the other point in the middle of the dot, and then I can go up to here and kind of mark that distance, actually just hold the point there and spread the thing out to this distance. Then I go over one doubling displacement, and now I can make a mark. I can actually make an arc and then do a construction. I'm not going to do the construction. It'd be kind of hard to do on a scale this small, but I can locate the point on that arc that's directly above this x value, and that will be my new point on the graph. Then I can double that y value. Now this compass won't manage that, but I come over here and I go here, and I believe I get a point directly above this x value. So that's going to be about here. And then I can double that again. Well, here it is. So come over to here, double it, and I'm up here. I have to kind of get in the way to make sure I'm reasonably located above and below this point, or well, with it, above this point, with this point below my new point. And then I could double that out here, and that would get me a point up here in my writing. It'd be about here, but I'm going to mark that lightly. Now, what happens if I want to set a point here or here? Well, point here, you should think of this. What do you think? How am I going to get this point? Well, from here to here, the y value has to double, which means that the y value from here to here is going to have to be cut in half. So I'm going to spread this. Well, I can do, I'm spreading, the compass won't help, but I can mark my arc here, draw the bisecting line, and that's way too small to actually show it, but it's going to give me a y value about here, so I can kind of project this y value over here, and I see that I'll have a point here. and then I'm going to cut the y value of this point in half. It'll give me a point very close to the x-axis. If I draw the point with the diameter of the others, it's probably touching the x-axis but not centered on the x-axis. So I have my original point, and I have this constructed point and this one to the left, and this constructed, well, these three constructed points to the right. So now I'm going to be able to simply connect these points with a smooth curve, and it's pretty easy to do that. And I can continue the curve up toward this point that I think is going to be it up here. And then I have an exponential graph. Right now that graph is unlabeled. When I say unlabeled, that's not really the word I want to use, but we don't have a y-axis. So the y-axis has yet to be drawn, and the y-axis can be drawn anywhere. So I'll put the y-axis anywhere. So when you look at this, so we construct the graph. Then we put the y-axis anywhere. So I'm going to put it, oh, what the heck, right here. It doesn't matter where I put the y-axis. This graph now represents any exponential function. This graph can represent any exponential function. So the graph can now represent any exponential function. Y equals f of x equals b to the x. Okay. Or y equals f of x equals a times b to the x for positive value of a. If there's a negative value of a, then the graph is just flipped over upside down. Has the same look. And the other thing is, for this graph, b has to be greater than 1. Okay? Now, if b is less than 1, we can also construct the graph, and we'll talk about that. And it's really a simple change that we have to make. But for right now, there's some restrictions. This graph represents a graph of b to the x as long as b is greater than 1, or a graph of a times b to the x as long as a is greater than 0. Again, it didn't matter where we put the y-axis, but now that we have it there, that's it. And the other thing I'll note is that the doubling displacement and the value of b are closely related. So the doubling displacement, and probably put this over here, put it over here. The value of the doubling displacement implies the value of b, and vice versa. The value of b implies the value of the doubling displacement. So if you know one, you can find the other. And there's a simple relationship between the two that we'll look at later.